Hello, Alvin ISD geometry students. In this video, we're going to talk about sample space with the fundamental counting principle. If you haven't already watched the video for sample space with the tree diagram, you may want to go back and watch that one first. To start off, we've got a quick reminder about what sample space is. So sample space is the set of all possible outcomes. Typically, sample spaces are displayed in three different ways. The first one's with an organized list, or just a list. The second would be a tree diagram. That's the video that we discussed a minute ago. And another way would be a table. Fundamental counting principle. So the fundamental counting principle is an alternative way to find the number of possible outcomes. Typically, this is used when other methods are not practical. In other words, you've got a large number of events or a large number of possible options for each event. With the fundamental counting principle, in that instance, we would take the total number of possible outcomes for each event and then multiply them. So if there were 3 different events, each of the events had 10 possible outcomes, that would be 10 times 10 times 10, or 1,000. So here's our first example. Haley has selected a size and overall style for her class ring. Now she must choose from the ring options shown. How many different rings could Haley create in her chosen style and size? So here are her ring options. She has metals, finishes, stone colors, stone cuts, Side 1 activity logos, Side 2 activity logos, and band styles. So you can see for each of those all the different options or choices that she would have for each one of these, I would call those events. So the first thing we would do to use the fundamental counting principle is just multiplying each one. So we'd have 10 times 2 times 12 times 5 times 20 times 20 times 2. In order to do that, then you would find out that Haley would have 960,000 different ring options. Here is our next example. Find the number of possible outcomes for each situation. So our first situation is the answer sheet shown is completed. So if I'm looking at this answer sheet, I've got 10 different problems. For the first 6, there are 4 different options that I could choose. And for the last 4, there's 2. So using the fundamental counting principle, we would say, for number 1, we would multiply the number of options for 1, 2, 3, 4, and so on. So here we go. The first 6, like we talked about, I'll put it here. The first 6 have 4 different options, and the last 4 have 2 options. So we'd be literally multiplying 4 times 4 times 4, and so on, times 2 times 2 times 2. Whenever we do that, we get 65,536 possible outcomes. Here is our next example. Find the number of possible outcomes for each situation. This time our situation is a die is rolled 4 times. So each time we roll, it would be a different event. So we've got 4 different events because we'd be rolling the dice 4 times. The die, or a numbered cube, is 6-sided, so it would be 6 times 6 times 6 times 6, or we would have 1,296 possible outcomes. So here's the last example, but we can actually use the fundamental counting principle to find the probability of something. So in this case, we've taken the last one, and a die is rolled 4 times, and a 1 is rolled each time. So we know that there's 1,296 possible outcomes. But in order to find the probability, in order to find the probability of an event, it's the number of desired outcomes out of the number of total possible outcomes. So if I know that there's only one time that this would happen out of the total 1,296, that would be 1 out of that. But using the fundamental counting principle, we can find the probability just by saying the probability of rolling a 1 the first time, the probability of rolling a 1 on the second roll, probability of rolling a 1 on the third roll, and the probability of rolling a 1 on the fourth roll. So it'd be 1/6 each time, or 1/6 times 1/6 times 1/6 times 1/6, which gives me the 1 out of 296. Here is our next example. In the Junior Student Council elections, there are 3 people running for secretary, 4 people running for treasurer, 5 people running for vice president, and 2 people running for class president. So in order to find the number of total possible outcomes, we would do using the fundamental counting principle. We would multiply the number running for secretary times the number of running for treasurer times the number of running for vice president times the number of running for president. So that gives us 3 times 4 times 5 times 2, which is 120 possible outcomes. Here is our next example. Faria, go ahead and take a moment, pause the video, and try this one on your own. When signing up for classes during his first semester of college at Texas A&M, Frederico has 4 class spots to fill, with a choice of 4 literature classes, 2 math classes, 6 history classes, and 3 film classes. Go ahead and pause the video and try it on your own. All right, in order to find this using the fundamental counting principle, we know that there's 4 different events, literature, math, history, and film. So I would multiply the number of literature times the number of math times the number of history classes times the number of film classes, which gives me 4 times 2 times 6 times 3, or a total of 144 possible outcomes. Here is our last example. Nisi is choosing 1 each of 6 colleges, 5 majors, 2 minors, and 4 clubs. So I would take number of colleges times the number of majors times the number of minors times the number of clubs. That would be 6 times 5 times 2 times 4, which gives me 240 possible outcomes. Thank you.